The question is oxygen melts at minus 219 degrees and boils at minus 183 degree. Okay, at which temperature is oxygen a liquid? According to the Cambridge multiple choice, we should exclude two options. These two options are not included in they are very far from options. Like what? Like the 25 degrees. We are talking about minus and we are talking about oxygen. So how can we use 25 degrees? So that one is excluded. What else also are excluded or is excluded? Now he is saying here the oxygen melts at minus 219. So less than 219, I mean less than in degrees. So yeah, I mean less than 219 by minus like 225. All this degrees, the oxygen it will be solid. So why? Because it will start to melt in this degree. So if we need to draw a line of melting or boiling point for the oxygen gas. So he said in 200 or minus, this is if we consider this is 0, okay, and here this is minus 219, for example. Okay, less than 219 here, all of the substance here is solid substance, and he is talking about what? He's talking about the liquid, or which temperature the oxygen should be liquid. So it should be, of course, more than 219. Okay, so our choices now is minus 175 and minus 189. Which one is correct? And he told us here, and boils at minus 183. So if we write here 183, this number is the boiling point. Okay, so less than this number here, we are talking about the liquid. More than this number, minus 183, okay, this is the gas. So this oxygen gas starting from 183, okay, it will be, of course, it will be a gas, okay, but less than 183 here in this area, it will be liquid. So where is the liquid point? Okay, starting from 219, minus 219, up till minus 183. Through this period, this is a liquid gas. So which one we should choose? Minus 189 degree. This is the correct answer for this question. The question is the pressure of a sample of gas decreased. So you decrease the pressure of the gas. The temperature is kept constant. Which row describes the effect of the particles? Okay, here we have a constant factor, which is the temperature, and changed factor, which is the pressure. Okay, as the temperature is a constant number, so there is no any change in the kinetic energy of our particles. There is no any increase or decreasing in the movement. So if you are talking about the movement of particles, so we should exclude the two slower. Why? Because there is no any change here in temperature. There is no any effect in kinetic energy. So which one it should affect? No change in speed, no change in speed. Both of them are correct here in the movement of particles. But the other side, he's saying about the collision between particles. By decreasing the pressure, we are decreasing the chances of collision. So occur less often or occur with more forces. No, it's occur with less often. So the correct answer is C. The question is, rubidium has two isotopes, okay, RB85 and RB87. So what can we detect from these numbers? We have here similar two numbers, 37, this is the atomic number, and the mass number for both of isotopes are different. Which statement explains why both isotopes have the same chemical properties? Okay, why they have the same chemical properties? Okay, the chemical property depends on what? Depends on which number here in these numbers? No one of these numbers, but it depends on the electron number. Okay, the first option, they have the same number of protons. Of course, they have the same number of protons, but let me check. They have the same electronic configuration. Oh, Yeah, this is correct. But which one we should exclude first before you choose the number of proton or the electron configuration? They have different number of neutrons. Yes, they have different number of neutrons, but as they have different number of neutrons, they are isotopes. But this is not affecting in the chemical properties, but affecting in the physical properties on the mass. They have different mass, of course, they have different mass, but not affecting in the chemical properties which we are looking for. So here we have another the two options, the first one and second one, we should choose between them. They have the same number of protons. Yes, they have the same number of protons, but the number of protons doesn't detect or it doesn't affect or it doesn't give us indication for the chemical properties, which give us the indication for chemical properties, the configuration of electrons, how many electrons are in the last shell. Okay, how many electrons in the last shell? So the correct answer here is B. The question is, which diagram shows the covalent compound or covalent bonding in a molecule of carbon dioxide? Okay, carbon, we know it's composed of carbon and oxygen. First of all, carbon composed of how many electrons in the outer shell? It has 4 electrons in outer shell. These 4 electrons, it can make how many covalent bond? It can make 2 covalent bond. Oxygen, it's in group number 6, so it has 6 electrons in outer shell. Okay, 1, 2, 3, 4, 5, 6 electrons. So it can make how many covalent bond? It can make 2 covalent bond. The oxygen can make 2 covalent bond and carbon can make 4 covalent bond. So each carbon, it need to react with 2 oxygen, and each one, it has to make a double bond with it. So the carbon can make a double bond with the first oxygen and can make another double bond with second oxygen to give us CO2. So we should choose the correct answer, which is C double bond O, C double bond O. The question is in the bonding structure of melting point of sodium chloride and sulfur dichloride are shown as we see here in this table. Sodium chloride bonding is ionic and sulfur dichloride is covalent. The structure here is giant structure and that one is simple molecular. As we see here, the melting point for sodium chloride 801 and for sodium sulfur dichloride is minus 121. The question is, why does sulfur dichloride have a lower melting point than sodium chloride? Of course, it depends on the kind of bonding. The first one, sodium chloride, the bond between sodium and chlorine is ionic bond, and this bond is very strong, making or letting the sodium chloride to give us something is called giant lattice compound. This giant lattice compound, it needs too much energy to break down these bonds and melt it. In other hand, sulfur dichloride is a covalent bond and its shape is a simple molecular which need less much energy, less than the ionic. So the melting point for that one, which is covalent, as it's a very weak bond and the molecular forces between the molecules in case of sulfur dichloride, which is van der Waals forces, are very low. So the melting point for the sulfur chloride, it should be low. So which one is correct according to this explanation? The first option is the covalent bond in sulfur dichloride are weaker than the attractive forces between the molecules. No, not this option. The covalent bonds in sulfur dichloride are weaker than the ionic bonds in sodium chloride. Not this issue, because we are talking about the intermolecular forces between molecules. The attractive forces between molecules in sulfur dichloride are weaker than the attractive forces between the molecules in sodium chloride. No, we are talking about the kind or the relation between the bonds, the kind of bond, and the molecular or intermolecular forces. The attraction forces between molecules in sulfur dichloride, okay, are weaker than the ionic bonds in sodium chloride. Yeah, this is correct answer. So here he is mentioning this option, mentioning for the kind of bonds which is ionic bond in sodium chloride, which is very strong bond that needs too much energy to break it down, and also mentioned for the van der Waals forces or the weak forces between the molecules of sulfur dichloride. So the correct answer here is D. The question is, diamond and graphite have giant covalent structure of carbon atoms, of course. Which statement describe the graphite? It has a strong, rigid three-dimensional structure. Of course, no, it's not strong, not rigid, dimensional. It has four strong covalent bonds between each carbons. No, the graphite, it has just three covalent bonds between the carbons. Okay, and here we have one electron in each carbon is delocalized electron. So the second option is not correct. It has layers which can slide over each other. Yeah, that one is correct. It has layers. They are not completely connected with each other as layer, so each layer is separated from the other one. It has no delocalized electrons. No, it has delocalized electron, so the correct answer here is C. So the difference between the graphite and the diamond, as we said, it has this shape of bonding. It has four bonding like that, okay, and each carbon it has four covalent bonds between it and the neighboring carbons. But in case of graphite, each carbon it has just three bonds like that, and each carbon it has delocalized one electron, and this one electron, which is delocalized electron or free mobile electron, is the main reason for good conductivity of graphite more than diamond. So graphite is good conductor, or can conduct electricity more than diamond. Diamond cannot conduct electricity, but diamond, as it has a very strong network, so it's a very rigid and very strong compound, but more than the giant of graphite. The question is, which row explains the malleability and electrical conductivity of a solid metal? So we are talking about here metal, and this metal, to give us a solid, it must have something is called metallic bond, and metallic bond is attraction force or electrostatic attraction force between positive ions, okay, of this metal and the free mobile electron which orbiting or swimming around the. So we have here a cloud of electron or sea of electrons swimming and moving between the positive charges. So what's the main reason for malleability and for the conductivity? The first one, we should exclude two options which they are wrong. Malleability, delocalized electron can move free through the structure. Of course, malleability, it doesn't mean, or it doesn't have any relation between the electron or delocalized electrons and the movement. So here we should exclude the first one and second one. So the malleability here is the ability of metal to change its shape, and this ability to change its shape, its ability is due to rows of positive ions can slide over each other. These rows of positive ions can move or slide over each other, as we have here metallic bond. So the both C and D according to malleability are correct, but we should choose one from the other side. Electrical conductivity, this electrical conductivity in metallic bond is due to this delocalized electrons which is moving, these electrons which are moving and orbiting around the positive charges or around the cations. Okay, so the movement here for electrons or the sea of electrons. Here in this side, delocalized electrons can move free through the structure. Yes, this one is correct. Positive ions can move. No, positive ion cannot move. Here we are talking about the delocalized electrons which can move. The correct answer here is C, as it has both of the two options for malleability and electrical conductivity are suitable to describe the solid metal. Rows of positive ions can slide over each other, and delocalized electrons can move freely through the structure. So the correct answer here is C. The question is, the equation of the composition of ammonium carbonate NH4 2CO3 is shown here as we see it here. And this is the molecular mass for ammonium carbonate. The total volume of gas produced is 360 centimeter cubed at room temperature. Which mass of ammonium carbonate NH4 2CO3 is decomposed? So how can we detect the mass? The mass is equal, from, as we know, mass equal number of mole multiplied by the molar mass. Okay, so now we need to find the number of mole of ammonium carbonate. From where? From the equation, or from the stoichiometric equation. And he gave us an information. He said the amount of gases produced in that reaction 360. How many gases do we have here? We have two gases, carbon dioxide and ammonia. But here we have just 1 mole of carbon dioxide and 2 moles of ammonia. So these 2 moles and 1 mole of carbon dioxide, they are 3 parts or 3 moles. We need to know in 360 centimeter of gases, how many mole do we have? So we should find the number of mole of gases, total gases. So number of total gases moles equal 360 divided by 24,000 centimeter cubed, to find what? To find the number of moles, which equal 0.005, okay, which equal 0.015 mole. Okay, this is the total number of moles for all gases. How many mole of gases do we have according to stoichiometric equation? 3 moles of gases. So we should divide this number divided by 3. As we have here the number of moles of ammonium carbonate is 1 to 2 to 1. So here the number of moles of gases are 3, and here the number of moles of ammonium carbonate is 1. So we should divide this number by 3 to find the number of moles of ammonium carbonate, which equal 0.015 over 3 equal 0.05. 0.005. Okay, what's this number? This is the number of moles for ammonium carbonate. How can we find the mass? Now we multiply this number by the molar mass. So the mass equal 0.005 multiplied by the 96. This is a molecular mass number, which should gives me 0.48 gram. Okay, so which option is this? That option is B. Okay, so this is a correct answer, is 0.48. So here this question, it depends on how many mole of gases are collected, and according to the volume of gas we can find the number of moles, the total number of moles for all of gases, and from the stoichiometric equation and the ratio between reactant and product, we can detect 1 mole of the reactant and 1 mole of ammonium carbonate is related to 3 moles of the total gases. Okay, the number of moles of gases, we can divide them by 3 to find the number of 1 mole, and from this number of moles, which is 0.005 multiplied by 96, which is given by the question, this is a molar mass, it can give me the answer, which is 0.48. So the correct answer here is B. The question is, what is the empirical formula? What is the empirical formula of a compound that contains 3.66 gram of hydrogen, 37.8 gram of phosphorus, and 58.5 gram of oxygen? Now we need to find the empirical formula. If we have the mass, how can we find the empirical formula from these masses? This mass is the total mass of one compound. To find the empirical formula, which is the ratio between the number of mole of each element. So from this mass, we should find the number of mole from each element. What element do we have? We have hydrogen, and we have phosphorus, and we have what? Oxygen. Okay, so to find the number of mole of hydrogen, how many gram of hydrogen do we have? 3.66 divided by the atomic mass number for hydrogen, which is 1, so equal 3.66 gram. Number of mole is 3.66. What about the phosphorus? Phosphorus, its atomic mass number 31. From where these numbers? From the periodic table at the end of this paper. Okay, how many gram of phosphorus do we have? 37.8 over 31. Okay, 37.8 over 31 equal 1.22 gram mole. Okay, then the oxygen, it's equal 16. So how many gram of oxygen do we have? 58.5 gram over 16 from the periodic table should give me 3.66 mole. Okay, now we need to find the ratio or the simplest ratio between this number of moles. Which number we should divide by? We should divide by the lowest number, which is the lowest number here, 1.22. So 3.66 divided by all of these numbers, the number of moles, we should divide them by the number or the lowest number here and to find the simplest ratio. The first one is 3.66 over 1 over 2.22 equal 3. So the number of hydrogen here is 3. Second one, which is 1.22 over 1.22, this is for phosphorus, equal 1. And this is the phosphorus. So we have 3 hydrogen, okay, and phosphorus is just one element. About the oxygen is 3.66 divided by 1.22 should equal 3 oxygen. So how many oxygen do we have? 3. So we have here 3 hydrogen, 1 phosphorus, and 3 oxygen. Which one has these numbers? Okay, so H3, the correct answer. The question is, aqueous copper sulfate is electrolyzed using graphite electrode. Which row identifies the product and observation at each electrode during the electrolysis? Let's explain this question. Okay, as we have here electrolysis cell, okay, and this is our battery. Our battery composed of negative and positive poles, and here we have electrodes. 2 electrodes are graphites. Okay, so these graphites are inert electrodes to prevent interfering with the reaction. What do we have here? We have a solution of copper sulfate. This copper sulfate composed of Cu and CO4, which is sulfite. Okay, so as it's aqueous solution, so it's composed of water, and this water we dissolve inside it is copper sulfate. What do we have in aqueous solution of copper sulfate? Copper sulfate Cu positive and SO4 which is negative, and it has also H from water which is positive and OH which is negative. So what do we have here in aqueous solution? We have Cu positive, we have SO4 negative, we have H positive, and we have OH which is negative. Perfect. How many positive do we have? We have 2 positives. Which are they? Cu and H. How many negative do we have? 2. SO4 and OH. Which one here got discharged first or more able to discharge before the other one? Okay, according to this explanation, we have here 2 electrodes. One is negative and the other one is positive. The negative one we call it cathode. And this cathode should attract that because it's a negative charge, okay? So it should attract toward itself the positive ones, which is copper and hydrogen. But according to the cation selectivity in this charge, we know the less reactive element, the less reactive cation or the less reactive positive charge should get discharged or should be discharged before the higher reactive. As we know, the copper is less reactive than hydrogen. So in cathode, we must find what? We must find Cu got discharged around the cathode. Okay, the element which got discharged, copper. Why? Because copper here is less reactive than hydrogen, so it should be got discharged first. So in cathode, which one we should choose? We should exclude that one. Okay, and we should exclude the last one too. So the the C, B, and D are not correct. What do we have now? We have copper as product, and here also copper as product. Electrode turns pink due to the copper. Let's check the anode. What do we have in anode? We have positive charge, and this positive charge can attract the negative parts. What are the negative parts we have here? In the negative parts we have OH group and SO4. Which one from these two is able to discharge first? As we know, sulfate and nitrate are not able to discharge at all. So if you saw in your question sulfate and nitrate, you choose the second one without thinking. Why sulfate and nitrate? They are not able to get discharge at all, and the discharging of OH group, it will produce oxygen gas as bubbles. Okay, it will produce here oxygen gas. So the correct answer here in anode, we must find oxygen as product and bubbles of gases, but not the C. So the correct answer here is A. Correct answer is A. Question is molten sodium chloride is electrolyzed using inert electrodes. Molten here, it means there is no aqueous solution, there is no hydrogen, there is no oxygen. So we have just one kind of positive, one kind of negative. The positive one is sodium and the negative one is chlorine. To draw this reaction or this electrolysis, we have here our battery, which has negative charge and positive pole, and this electrodes. Okay, so what we have here, we have molten sodium chloride, Na and Cl. Na is positive and chlorine is negative. So which one should discharge it around the negative cathode and which one should discharge it around the positive anode? As we see here, we don't have options. We don't have option as it's molten. So sodium as positive charge should discharge it beside the cathode with negative charge, and chlorine should be discharged here to give us Cl0. So the correct answer here in cathode we must find sodium. Which one here is it has sodium in cathode? Just D. And in anode we have chlorine. So the correct answer here is sodium and chlorine in cathode and anode. So the correct answer is D. The question is, the equation for formation of ammonia is shown as we see here, Na2 plus 3H2. This is a hyperprocess equation to give us 2NH3. The reaction pathway diagram for the reaction, as we see it here and we know it well, is exothermic reaction. Okay, this is the pathway is exothermic reaction. The amount of energy which we need to initiate this reaction, which we call it activation energy, equal positive 250. And by starting this reaction, after we taking this 250 kilojoule, the reaction will get started, and to produce 2 moles of NH3, it will release minus 342. What is the delta H here? The enthalpy change, which is asking about it. The enthalpy change, or the difference between absorbed energy and the released energy. Okay, it's very clear from the diagram. This amount of energy, okay, from this point up till this point. So as this reaction absorbed positive 250 and released minus 342, the difference between them equal minus 92 kilojoule. This minus 92 kilojoule, this is the enthalpy change for this reaction, as it's exothermic reaction. Okay, the reactants and product, they are in different levels of energy. The amount of energy which is stored in reactants more than the amount of energy which is stored in product. It means this reaction absorbed less than which released, the amount of energy which got released from this reaction. That's why the product energy is less or lower than the amount of energy in product. So this reaction is exothermic reaction, and the correct answer is minus 92. The question is, sulfur dioxide is converted to sulfur trioxide in contact process. Okay, to produce sulfuric acid. The condition used are 450 degrees and 200 kilopascal with vanadium, of course. Okay, vanadium oxide as a catalyst. Which row describes and explains the effect of changing condition on the rate of reaction? Let's exclude the wrong one first. Here, no catalyst. Okay, no catalyst, the rate of reaction got decreased, of course. The activation energy, why? The explanation of activation energy is higher. That's correct. So by using the catalyst, we are decreasing the amount of activation energy. So if we don't use the catalyst, the rate of reaction got decreased. Why? Because activation energy will be got more higher. So the first one is correct. The second one, higher pressure, it will lead to increase the rate of reaction. Yeah, it will increase. The particle have more kinetic energies. This explanation is not correct. They are not relatable. Higher pressure, it means higher rate of reaction, of course, but is not because the particles have more kinetic energy. This half kinetic energy is related to temperature. Lower temperature, it will decrease the rate of reaction, of course it will, but the particles collide more frequently Of course, no. Decreasing the temperature, it will decrease the frequency of colliding. D, lower pressure, higher in rate of reaction. Of course, no. Lower pressure, it means lower in the rate of reaction, so that one is not correct. The C is not correct. B is not correct. The correct answer is A. By no catalyst, the rate of reaction will get decreased, lower rate of reaction, and explanation, the activation energy is higher, or the amount of energy which we need to activate or to initiate this reaction got increased by not using the catalyst. The question is, hydrogen gas reacts with iodine gas to form hydrogen iodide gas in an equilibrium reaction. H2 gas plus iodine gas equal or gives us 2HI gas. The delta H here is, he mentioned for delta H, which is positive 26.5 kilojoule per mole. So this reaction is endothermic reaction. Which changes increase the yield of HI? So which one or which changes can shift the equilibrium to the right side? Okay, the first one, adding catalyst. Can shift it to right side? Of course, no. Why? Because catalyst can affect or should affect in the two pathways, the forward reaction and the backward reaction. So the adding catalyst here, it will not affect or not shift the direction, or will not shift the equilibrium to the right side, but it will give me equal affecting in the both forward and backward directions. 2, adding more hydrogen gas. Adding more hydrogen or increase the concentration of hydrogen gas, of course, it will lead to shift the equilibrium to the right side. So the number 2 is correct. Increasing the pressure. Increasing the pressure will not affect or will not give me this effect. Why? Because increasing the pressure, it will affect in both of the two directions. As we have here, all of the reactant and product or gases are able to affected by the pressure. So increase the pressure here and increase the pressure here, it will give the same or equal effect in both of the two pathways, forward and backward. So the increased pressure, it will not affect. Increasing the temperature, this reaction is endothermic, and we know increase the temperature of endothermic will shift the equilibrium to right side. So any endothermic reaction, if we increase the temperature of reactant, it will shift the reaction to the right side. So the correct answer here is 2 and 4. Which one here? It has 2 and 4, D. So the correct answer here is D. The question is, in this equation for the reaction of carbon with carbon dioxide, as we see it here, carbon and carbon dioxide gives us carbon monoxide. Which row identifies the carbon atom that is reduced and its a change in oxidation number? Okay, so here we are talking about the oxidation number. We should detect the oxidation number for each element before starting. The elemental carbon, it has oxidation number 0. The carbon here in carbon dioxide, it depends on the oxygen. Oxygen, it's -2. As we have 2 oxygen, so the total oxygen oxidation number is -4. So this carbon is +4. Okay, and here in carbon monoxide, we know oxygen is -2, so carbon here is +2. What is the question? The question is, which row identifies the carbon atom and that is reduced? Which carbon here, the elemental carbon or carbon and carbon dioxide got reduced, and it's a change in the oxidation number. The first row, carbon and carbon dioxide, yes, of course. Which one got reduced? Look for the oxidation number for the first one. The first one, or the elemental carbon, from 0 to be +2. So got oxidized or got reduced? Got oxidized from 0 to +2, the oxidation number increased. It means this carbon got oxidized. So carbon in the elemental carbon is not correct. So we should exclude the last two. We should choose one from the A or B. Carbon and carbon dioxide got reduced, of course, but from what? From +4 to be +2. Which one here is +2 to +4 to +2? The B, +4 to +2. So the correct answer here is B. B is the correct answer.